Chapter 5, Energy, Part 2 of 3. The Laws of Thermodynamics. Thermo means heat, and dynamic means movement. The laws of thermodynamics. Zeroth law of thermodynamics. Thermal equilibrium. When no heat flows between two thermodynamic systems that are in contact with each other, the systems are in thermal equilibrium. The first law of thermodynamics. Conservation of energy. The total amount of energy never changes. Energy can neither be created or destroyed. Energy can flow or change its form, but the total amount of energy never changes. Second law of thermodynamics, the usefulness of energy. The second law of thermodynamics states that the efficiency of any system must be less than 100%. Eventually, every type of energy is transformed into quote-unquote low-grade energy in the form of heat. The energy does not disappear, it is transformed into a less useful form. The heat produced by an aircraft will eventually be radiated away from Earth and outer space. The third law of thermodynamics. The third law of thermodynamics states that it is impossible to reach a temperature of absolute zero. Fundamentals of thermodynamics. A thermodynamic system is a quantity of matter or a region in space that is separated by a boundary from its surroundings. For example, coffee inside of a thermos. Thermodynamic systems can be opened or closed. An open thermodynamic system allows mass and energy to flow freely through a boundary from the system to the surroundings. Your lungs are an example of an open thermodynamic system. A closed thermodynamic system does not allow mass to be from the system into its surroundings, but it does allow energy to be transferred across the boundary in the form of work or heat. An example would be a light bulb. Renewable energy sources. Renewable energy are those that can be replenished in a short order. The five most common renewable energy sources are biomass, hydroelectric power, geothermal, wind, and solar. Renewable energy sources. Biomass. Living or recently living plant material is the source of all biomass energy or bioenergy. Wood is the largest biomass energy source today. Other sources of biomass include living or recently living plant material, dedicated energy crops, fast-growing plant matter, forest, mill, and agricultural waste, organic consumer waste, and organic industrial waste. Biomass power. Biopower uses the chemical energy stored within biomass to generate electricity. Direct firing. The majority of biopower plants use direct firing systems that work by burning biomass to produce steam that is used to turn the blades of turbines. The turbines are connected to generators that produce electricity. Co-firing. Co-firing refers to blending biomass with fossil fuels in existing power plants. Gasification. Gasification systems expose biomass to high temperature in an oven with limited oxygen to convert biomass into synthesis gas, a mixture of hydrogen and carbon monoxide. Pyrolysis. Pyrolysis uses a thermochemical process that is similar to gasification. In pyrolysis, oxygen must be completely excluded while the biomass is exposed to high temperatures. This will pyrolyze biomass to a liquid rather than gasify it. Landfill gases. Natural decay of biomass produces methane gas that can be captured and used for power production. Anaerobic digestion. Anaerobic digestion can also be used to produce methane from biomass. Naturally occurring bacteria are used to decompose biomass in the absence of oxygen in closed vessels. This decomposition produces methane gas that is suitable for power production. Ethanol. Ethanol has already proved to be realistic, efficient, and economical. Ethanol is made by fermenting and then distilling simple sugars from corn, sugarcane, or cellulosic feedstock. There are two ways to convert biomass into ethanol: sugar platform and thermochemical conversion processes. Sugar platform process. All sugar platform processes use living organisms to convert simple sugars into ethanol. Thermochemical processes. It uses enzymes to break down the cellulose and woody fibers so that more of the plant can be used to make cellulosic ethanol. These processes transform all the non-mineral components of the biomass into synthesis gas or syngas. The syngas is passed over a catalyst that accelerates the conversion of syngas into ethanol and other alcohols. Hydropower. Hydroelectric power plants take advantage of naturally occurring continuous process called the water cycle. Water moves from high ground, eventually making its way back into the oceans. The force of this moving water can be extremely powerful. Hydroelectric power plants need water to operate. Waterfalls, such as Niagara Falls, where the first hydroelectric power plant was constructed. Dams are commonly built in areas where the walls on either side of a river can produce an artificial lake or reservoir. Dams can increase power pressure by raising the height of the water behind the dam, and they can regulate the amount of water flowing through them. Hydroelectric power plants use water to spin the turbines, the power electric generator. A common hydroelectric power plant has three major components: a powerhouse, in which turbines spin generators to produce electricity, a dam that can control the flow of water, and a reservoir where water can be stored. To generate electricity, a dam opens its gate to allow water from the reservoir to flow down through the gigantic tubes called penstocks. A turbine is positioned at the end of a penstock where the fast-moving water spins the blades of a turbine. The turbine is connected to a generator which produces electricity. Geothermal. Geothermal energy makes use of the heat from within the earth. The word geothermal comes from a combination of the Greek words geo, meaning earth, and therm, meaning heat. High-temperature geothermal energy. When geothermal reservoirs made of magma and a constant supply of water, the water and steam are used to generate electricity at power plants used to production wells. There are 4 different types of geothermal power plants: flash steam, dry steam, binary, and hybrid. Flash steam plants. A flash steam plant works by pumping into geothermal reservoirs where the water is superheated and then pumped back to the surface. When the water reaches the surface, it rapidly boils and turns into steam. The steam is used to turn a turbine, which spins a generator and makes electricity. Flash steam plants produce no pollution. Dry steam plants. Dry steam plants use the steam escaping from the reservoir to turn a turbine, which spins a generator to produce electricity. Binary power plants. Binary power plants produce electricity using hot but not boiling water. The heat from the geothermal hot water is passed through a heat exchanger that transfers the heat to another liquid to produce electricity. The water from the geothermal reservoir is pumped through the heat exchanger and then is returned back to the reservoir to be reheated and recycled. Hybrid plants. Some power plants combine flash and binary systems to make use of the steam and hot water. Geothermal heating and cooling. Geothermal heating and cooling systems work by pumping water through long pipes buried underground. The water is cooled or warmed, depending on the season, by the Earth's crust and returned back to the building. The water then enters a heat exchanger, which transfers the heat to the building during the winter months and transfers heat away from the building during the summer months. The water is then sent back into the pipes buried below the ground to begin the process over again. Geothermal heating and cooling systems can reduce heating and cooling costs by 50 to 70%. Wind. Wind is caused by Earth's uneven heating. Wind is the flow of warmer air mass toward a cooler air mass. Wind turbines work like electric fans, but in reverse. Instead of the fan making the wind turbines are used to produce the electricity. The blades are connected to a gearbox that increases the revolutions per minute of a generator shaft. Solar. The sun is constantly radiating enormous amounts of energy. A greenhouse is an example of a solar collector. Many homeowners around the country use solar energy for space heating. Some are able to save upward of 50% off their home heating costs. There are 3 types of solar space heating systems: passive, active, and hybrid. Passive solar heating. Architects designing these structures are able to maximize the amount of solar energy absorbed by changing the size and placement of windows and altering the shape of the structure itself. Active solar heating. Active solar heating systems use mechanical equipment such as blowers and pumps and an outside source of energy to maintain a constant temperature within a system. This can save the average homeowner hundreds of dollars every year. Photovoltaic cells. Photovoltaic or PV cells are used in some active solar heating systems to generate electricity. PV cells are made of semiconductor materials such as silicon. When light strikes a PV cell, its energy is absorbed by the semiconductor. This generates a voltage across the cell, which allows free electrons to move through a circuit to power electrical devices. Solar power plants. Much like solar cells, solar power plants use energy to generate electricity. The light must be focused to produce the high temperatures required to generate electricity. There are 3 types of solar power plants that use mirrors of other reflective surfaces to magnify the sun's energy: solar parabolic troughs, solar parabolic dishes, and solar power towers. A solar parabolic trough. Solar parabolic troughs use miles of reflective troughs that focus sunlight onto a pipe located at the parabola's focal point. A working fluid such as oil is circulated inside the pipes to collect the heat energy and transfer it to a heat exchanger. The heat exchanger heats water to produce steam, which drives a turbine connected to a generator to produce electricity. Solar parabolic dish. A solar parabolic dish uses mirrors in the shape of a dish to collect and concentrate the sun's radiant energy into a small area where a receiver is located. The receiver transfers the sun's energy to a heat engine that converts heat to electricity. Solar power towers. Solar power towers use hundreds of large sun tracking mirrors to focus the sun's energy on a receiver at the top of a tower. A working fluid is used to generate electricity. This ends Part 2.